Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight. This is the second episode of our three-part discussion with David Knight, the CEO and co-founder of Turbine. In episode 1, we explored the company and its market. Now we'll deep dive into the technology behind the solution. So you guys are biting off a huge project here, right? Because you're doing everything from developing a new contextual layer for specifying the metadata, for licensing data, pricing data, I think securing the data. One of the classical use cases is that two competitors both use the same equipment, and the equipment manufacturer would like access to the equipment data so that they can provide better service and understand how their equipment is being used, feed it back into R&D, and improve the quality of the equipment itself. But neither competitor wants to provide that data because it could be potentially used by their competitors. So how do you provide that data in a secure way to a qualified user and make sure it can't be used by non-qualified users or it's anonymized? Let's go into the technology a little bit, because I think some of these areas, if we look at that particular case, that's it's a legal issue, but it's also a technical issue. How do you build the technology so that you can provide the business decision makers with confidence that when they provide data to a specific user, it's only going to be used by that user in a particular way? Data is obviously more challenging to secure than other things because it can be copied and then you lose track of how it's actually being used and by whom. How do you either address this today? How are you planning to address this? Blockchain is one technology that's been proposed or explored as an alternative. What is Turbine built on for this particularly challenging issue of anonymizing and securing and making sure that data is only used in the prescribed ways?
So that starts with, first of all, a really serious scan of the landscape and getting input from quite a lot of companies. The last count, which we actually did count for an investor the other day, there's been 193 companies who we've met with, not just an email, but actual physical meetings in the last 2 years. And that count will be higher if you're listening to this podcast in a few months' time. And I should also mention that 100% of the companies and government agencies from the U.S. and other countries that we've met with came to us. We have not I haven't hired a head of biz dev yet, so everything is inbound. I could go into how that happened, but we have had so much interest in this, and simultaneously these fears about, I don't want my data wantonly used out there. So we started with listening to people and what their problems are, and knowing that this is also new for everybody, that they probably don't even know what their problems are going to be until they face them or somebody presents them as, would this be a problem for you? But it really boils down to, one, right now I'm collecting a lot of IoT data and it sits in silos, or I even discard it because I don't have enough storage for it and it's getting ridiculous. Or I use 2% of it and the rest is never used. It's my data kind of lives in my world and it doesn't get out. Two is, okay, if the friction got removed from that process, then I could start to use that data with third parties for any number of reasons, depending on my industry and what I do. On the other hand, I'm really afraid of, how that gets conveyed and controlled. And then the third one, which is sort of the sexy, tantalizing one, is, I keep hearing that data is the new oil, but how much does a barrel of oil cost? We've had to spend a lot of energy on all three of those areas, like pylons. And each one of those breaks down to a bunch of other issues. I have to tell you that even though we're biting off a monster thing here, we have a lot of really smart people involved and get a lot of help and have a killer group of people involved. And we've also been thinking about this and doing something about it for 2.5 years. So it all seems like a lot when taken as a whole, but it would be sort of like Elon Musk telling you about this electric car idea, until he put you in the Tesla, it'd be hard to really get your head around it, but you have to build the whole Tesla to get somebody excited about it, right? So that's what we've had to do. So to get to how you really specifically answer that stuff, besides things like policy engines and eventual use of AI pretty thoroughly through the system, we are taking advantage of things like blockchain. So let me specifically talk about blockchain. So Blockchain is such a ridiculous buzzword now. I actually think that I'm hearing my mother talk about it. Not saying my mom's not kind of technical, but everybody's talking about blockchain. And the problem is a lot of people have kind of decided blockchain is a solution and not just a technology. And this happens with every wave of technology adoption. The irony is that blockchain all by itself is not a great way to convey data at all. It's actually very inefficient. But what it is good at is creating either a public or private or a public stroke private record of something. In other words, a distributed ledger that is not modifiable unless you're a super hacker with a really super computer system. So we started really looking at that. We decided that initially it would be very inefficient to use blockchain to carry the data itself. In fact, probably never. And talked to a lot of the top people. And as we learned about blockchain ourselves, we realized that the best use in our world would be blockchain to keep a record of when something, say, went from car company A into Turbine. There would be a parallel blockchain record that had nothing to do with the data. It's a separate thing. And this is like the call records or the manifest, call records for phone calls, manifest for shipping containers. There's a tracking similar thing for air traffic control. I mentioned those three as being very informative to the design and execution of Turbine. And then when it goes, so car company to Turbine, there's a blockchain record. Then from Turbine to user A, B, C, D, et cetera, N, there's a blockchain record for each of those. Lovely thing about using a public-private blockchain is that the provider or the user can actually audit the blockchain without even involving us. And honestly, in talking to a lot of large corporates and government agencies, it gives them comfort. The idea that they can go look anytime they want. Now, which blockchain becomes a big issue? And after talking to a lot of people, we decided that the blockchain schema to use is Hyperledger. Very, very happy with it. I would say in our case that probably the most influential partner in deciding to use Hyperledger has been IBM. They have a really good argument for why Hyperledger is the way to go. I would recommend to anybody out there, if you're looking at blockchain to track something internally or with trading partners, whether or not Turbine's involved. What the IBM people told me I took to heart, which was don't use a blockchain schema that has a whole bunch of Bitcoin type things on it, because that's where the hackers are going to focus. Those are also getting kind of bloated because it takes so much processing. And every time the chain is added to, it gets bigger and bigger and bigger. People processing cryptocurrency now measure the processing, aka mining, in kilowatts now. They don't even talk about clock cycles or storage. It's literally measured in power consumption in the data center. We need to stay away from all of that and just focus on using it as a great tracking mechanism. So in summation, we're happy with Hyperledger and we're implementing that now. On the other hand, we're not using cryptocurrency at the moment as a way to buy or sell data. Most big companies have told us they're not really settled with that yet because there's too much dynamicism to them. As we're recording this, it may be different in 6 months, but there's some very, very big undulations in, for example, the price of Bitcoin. Most big corporations have told us, you know what, I don't want a microtransaction or anything like that. What I want is Turbine sends me a bill every month. I take 30 to 60 days to pay it, and I use ACH, Automated Clearinghouse standard, to do that. But I'm happy with Hyperledger to keep track of things, but not for the money part. So based on all of that, we've, in the near term at least, settled on our schema. We do know that as things finally settle down, which is way beyond us, that's out in the big financial world, it would be very straightforward for us to add billings and payments using cryptocurrencies. But we decided to not base the system on those things until they really get settled. Now, having said that, under the hood of Turbine are a whole bunch of databases. There's a whole bunch of, quite a lot of code, that the logic. We also realized, and I've been in enterprise software most of my career, that we would really be dealing with big companies and not with consumers. And what does a big company or a government agency need? They need good documentation. They need APIs. They need example code and test cases. So we've already built a lot of that, knowing that we would immediately be asked for those things. You know, it's still definitely considered a tech startup. We had to build those enterprise class things before we even brought this out into the open. And technically, we really never announced Turbine. We've never done a big splashy announcement. We've just been kind of heads down building a system. But we've had so many of these companies, as I mentioned, come to us. It's sort of like what they call a soft announcement. And that's now leading to, as we're now in beta testing phase, which will last for a little while, we have a whole bunch of big companies very interested in kind of getting engaged and starting to put data through the system.
David, how does storage work here? So if you're tracking the metadata of data that's stored in a third-party database, I suppose easy enough. But then you're going to at some point potentially lose track of that data. The initial owner might only store it for a short period of time and so forth, and then the value is deleted. But if you do try to, of course, kind of store all the data that will be eventually coming through your systems, this is going to be a challenging problem, right? How are you addressing this? How do you decide what to store? And then what's the technology involved to be able to do this on a cost-effective way as the IoT data sets begin to scale?
Yeah, another excellent question. Before I answer that in the Turbine, what we're doing in terms of that, I will tell you some of the companies or government agencies that we've talked to about being involved in the Turbine environment have petabytes of data, just stunning amounts of data. And what really blows my mind is the following piece of information, that if you take consumer-generated video and still imagery out of it, IoT data or machine-generated data in general already exceeds the amount of human-generated data. And it's just getting bigger, obviously, exponentially, or actually it's not even exponential. It's faster than that, depending on what time interval you're picking. And exponential is kind of ethereal unless you assign it to a time, kind of a timeline. But if you take the machine-generated data as a standalone and forget that we're all generating gobs of data with our phones, it is stunning that you might have petabytes of data that are composed of like 2 kilobyte sets of datagrams. It's unbelievable. Whereas one video that I can make with my phone could be, a terabyte in 5 minutes. So with 4K video, knowing that a sensor never throws off a 4K video unless it's a video camera, it's throwing off, 2K of data here, 5K here, 1K here. It really is amazing how much data the IoT is throwing off right now. Having said all of that, it gets to the nub of your question, which is there's no way anybody would store all that in one place. It's not impossible, but it's totally impractical. So we started looking at, again, some very successful systems. For example, how do content delivery networks on the web like Akamai work? Those are unidirectional. They're oriented towards the web and not what we're talking about, but they are informative. And then we met somebody who I love to mention, who I call our secret weapon, brilliant guy named John Rossman, who helped create the entire merchant system and marketplace at Amazon. And he wrote a great book I'd highly recommend called The Amazon Way, that's not coincidentally available on Amazon. It's a book about what they did, how they built it, and the culture. And if you're looking at e-commerce, definitely a good read. And he was then researching, he worked on another book that's now out called The Amazon Way on the IoT. So it's a book about how that all might apply to the IoT. After meeting him and talking for a while, I was very inspired to say, well, maybe Turbine becomes the Amazon of the IoT. John is now on our board of advisors of Turbine, and so is involved with us. And one thing he's helped us with is looking at how Amazon, how did Amazon do distribution? So this leads directly to how we're going to do this with data. What Amazon is so sophisticated, they would say that based on everything you can imagine, weather, what's happening with sports, all sorts of things, they would decide what to keep in each regional distribution center. So they don't have the same thing in all the distribution centers all the time. It's very geographically focused. And Amazon is totally driven by their Amazon Prime, 2-day free shipping thing. If they can't get it to you in 2 days, things start to break. And they really want to achieve that promise. I'm a very devout Prime user, so I can tell you that almost 100% of the time they meet that promise. It's very rare that they don't. And given the plethora of different types of goods in there, millions of SKUs, it's staggering. I think they're up to about 500 million SKUs or stocking units. That means individual things. It's staggering. Now, imagine IoT data is even more abundant than that. So rather than deal with physical distribution, we're dealing with data distribution. So we kind of took a lot of those principles that have been working really well for Amazon and said, how do you do that with data where you've got devices that are geographically distributed, generating, some need the data, the users are probably not co-located. So we're working on a thing that I call a flying Pareto analysis. So Pareto was a mathematician. Anybody who's into mathematics or physics would know about a Pareto analysis technique. It's basically an expression of the 80-20 rule, or actually the 80-20 is an expression of Pareto. So, where they say that 80% of the time, 20% of the possible solutions will apply. The 70% solution is more or less a similar expression of a Pareto, the theory. So having said that, we're working on how you can leave the data where it is. Say it's a multi-petabyte database at a big manufacturer or say a big government agency, and then only retrieving what's needed when somebody or something calls for it, only the piece they need. And then over time, as edge computing becomes real, and we have like high-speed wireless around the streets like 5G, we'll be able to geographically, make copies of data or move data where it needs to be, like to the point of consumption that's most likely. And we'll even use some of our own data to figure out where that needs to be. So an example to put some, reality to this, future cars, self-driving cars will have a lot of sensors on. There'll be cameras. And one of the most interesting things is LiDAR, laser radar. Now, LiDAR shoots down in front of the car, sometimes behind the car, and it's trying to build this literal bitmap of what's around the vehicle as it moves. It's not a camera shot. It's literally a bitmap. It's getting an absolute reading of what's, 325.111 centimeters on that vector from the vehicle. And this is a staggering amount of data. So the car companies are trying to figure out how to they're barely able to process it on the cars themselves with current processor levels, but eventually that'll get miniaturized and you will see LiDAR just built into the skins of cars. And it turns out that as the car is looking in front of it, it's not just seeing what's at the level of the car, which you need for navigating the car. It's also seeing what's up and away, like what's up there, maybe, 200 meters down the road. Now, depending on the LiDAR. So that data just gets thrown away because it has nothing to do with navigating the car. But imagine you can do a mathematical transform on it to compress it, feed it into the turbine system. Now I know what's over that street. I know where there's overhangs. I can see where the trees are intruding on the power lines and probably should be cut. So somebody who does that can worry about that. I also see where the catenary wires are for trams in cities that have them. And I can see that a construction crane appeared that wasn't there yesterday, a whole bunch of stuff like that. And that could be useful for not driving a car, but flying a delivery drone down that same street. So imagine that cars driving down the street are generating data that could actually be used to help a drone deliver packages or tell you what's happening, with a whole bunch of other issues. Like, say I'm the first responder and a building's on fire, I might actually see what's happening with that before I even get there because the LiDAR is picking up smoke plumes and stuff like that. So what's really cool is that as we move to 5G-based edge computing frameworks where you have compute power at the street level, and this is all being worked on in different parts of the world, we're actually going to be able to distribute the turbine system itself. And this is part of why we're doing this external signaling and metadata layer to keep it separate from the data. It allows us to do all of this. And then we can make live Pareto decisions on where the data needs to be closest to the point of consumption. That helps us deal with the speed of light. It also helps us deal with not having to store everything everywhere all the time.
And then I suppose pricing is going to be a factor here. If a particular data set has been shown to have strong value on the market, then you'll have an incentive to store this in more locations, or to store it over a longer period of time, and to make sure that that data is available for the market when necessary. And if the data is shown to have relatively little value, then the pricing will probably impact the storage. Let's talk a bit around the pricing, because it sounds like right now you're working on a fairly simple framework for the initial users, which I think makes complete sense, but I imagine at some point it'll be moving maybe hypothetically more towards a Google AdWords model where every particular data set will be constantly bid on and the pricing will fluctuate based on demand. How are you envisioning? Maybe you can go a little bit more into what does pricing look like today and in 2018 for data, but also how do you envision the pricing of data evolving over the coming years?
So let's talk about pricing of IoT data. It turns out to be an extraordinarily complex subject when you start to really sit down and noodle on it. So we've been noodling on it. We're almost obsessed with things like knowing about the data, data quality, data contextual information, provenance, and that eventually all informs the pricing. So we did look at various models, like could you have an auction? Difficult with an auction, the way the world's kind of built today, because data is never scarce. You know, you can replicate one set of data a trillion times, but data could be rare. And part of the rarity could be just accessibility of the data. So we started to look at rarity versus scarcity. Then we looked at, I could say in a quick high level thing, the world's really not ready for auctioning this stuff yet. It's just really not ready for that. But the ad world is a little more, it came along faster because there was already a known supply-demand set of issues. And inventory, which is an exotic concept when you're talking about online advertising, became kind of the driver. That's sort of their equivalent of scarcity. However, we've analyzed very deeply how all the big ad exchanges work, and we kind of discarded those as a good model for IoT data for a whole bunch of reasons. Let me get to the chase, if you will. So starting last summer, we decided we needed to really start actually looking at how do you price IoT data, knowing that there were so many variants, so many sources, so many potential use cases. Fortunately, a major car company came along right about when we were starting to really think about it, introduced by one of the very big consulting firms. And they said, jeepers, we keep reading these studies that say that eventually the data a car generates will be worth so much money that you won't even pay for the car. The car will be paid for by data, along with your power tools and your kitchen appliances. And they said, but we don't really accept that. We need to get down to brass tacks. What is the data from a car going to be worth now and in the future, especially when they go to a purely autonomous vehicle? So we said, great, we're looking for somebody to sandbox with us on that. So we started working on mathematically what's called a sensitivity analysis, where we eventually distilled it down to 21 variables that have to be resolved in order to price a given data type. Again, we go at the level of the metadata. So generally, most of what's behind a given metadata instance would have a similar price, although aging is also a factor. One of the 21 variables is what we call currency, meaning how recently did we get that data. In Turbine speak, we call real-time, meaning 1 second or less. If we get that data from its generation, and remember, we don't tend to talk to a single sensor, we're talking to maybe a million sensors or thousands at least, that it's handed to us at the cloud level. But there are cases where we could get the data that fast. That's real-time. As 5G becomes pervasive, we'll get more wireless things that are at that speed, obviously. Then between roughly 1 second and 1 hour, we call that near real time. And then after that, it's essentially archival. Now, I want to mention that some data is actually more valuable in aggregate and over time than in real time. So here's an example. If I'm trying to fly a drone between skyscrapers, I may need to know a lot of things. The drone's small, and so it doesn't have as many sensors as something like a car. So as we see delivery drones show up for real, we're going to have a lot of need for those devices to actually get data brought to it. Not all of that data needs to be from 1 second ago. A lot of the data could be from a LiDAR 20 minutes ago or even yesterday, because that doesn't necessarily change that much as far as what's in the sky. It is important, but it doesn't have to be sub-second. On the other hand, there is data you would want in sub-second or close. That may make it more valuable. On the other hand, the drone doesn't have a lot of money. So it's a drone. So if I'm flying 20,000 of those drones around, this Northern California, I would have the money to pay for it, but on a per drone, per instance basis, it wouldn't be a lot, even though I may need high currency or, short period, high currency data. On the other hand, if I'm doing a crop yield forecast, like somebody like, Climate Corp would do, I would actually not want 1 millisecond's worth of data. I need 3 years worth of data or 10 years worth of data for that area of the Earth that I'm analyzing using, say, UV spectral analysis or something. So because of that, we realized that timeliness is not the only factor. In fact, it's rarely the main factor that influences pricing. And sometimes the older data is more valuable. So we started to create this sensitivity analysis. Effectively, imagine a spreadsheet that's 1 foot tall and 6 feet wide. If you were to print it out on regular paper in a reasonable font, the reason it's so wide is because of all those variables you have to resolve. So that's what we're building right now. We're doing it with manual input using these worksheets because that helps us figure out what the AI needs to do. And that's sort of the general progression of how AI is working. Is you start with humans with real I, HI, human intelligence. And after a lot of test cases, you eventually figure out these sort of locuses or loci, I guess, the points form that tell you what you could automate. And in software, first you write a script. The next level of sophistication is first you type, then you write a script. Then you create algorithms, meaning normal, what we call code. Then you get to machine learning, where elemental things can be kind of laid out in a way that would let the software make its own decision within a very constrained set of parametrics. Then AI is where it can start to kind of learn and think for itself even more, to the point where it starts kind of looping and training itself. That is still not really here at the level of a general AI, but we have enough AI out there like IBM Watson that we can begin doing this with IoT data. The other thing I wanted to mention, because we haven't talked about it, is what about the analytics side? What about people that are looking for outcomes that drive business decisions, or even analytics that would tell you, whether or not to turn the ship left? We decided early in Turbine that on the input side, we wouldn't touch the data. We would leave it in its native form, which is safer than trying to clean it or normalize it because of the potential bad outcome of doing that I mentioned. So all the work is done in the control layer through metadata and other descriptors. At the output side, we realized that we could never be good at doing everybody's analytics for them. If we're an exchange, we shouldn't be doing their analytics. We do analytics on the data to contextualize it and do pricing, but we don't do the analytics that, say, give you a crop yield forecast or tell you how to improve the efficiency of machines in a factory or better routes for a truck. Instead, we provide all that information through APIs to people that have analytics and do analytics for a living. They could be inside of a big company, or they could be a standalone, even a startup, and give them the data, give them enough information to do a good job of the analytics. Then they can take their post-analyzed data. So essentially, you've taken a bunch of ingredients and made something with it. Once you've done analytics on data, you can no longer find the raw data because it's now been turned into something else. So as long as they're sort of well-behaved in terms of following the metadata construct, they can actually take that new thing they've invented with their algorithmic work on the data sets, and then put it into Turbine as a whole new data product. And as long as they didn't throw out the provenance information from the source metadata sets, they can encode that as a chain of provenance into their new metadata for their new analyzed data. And then when somebody buys that, we can actually go back through the provenance chain and make sure everybody who provided constituent pieces gets paid. We can even do things like say, well, that one thing can never leave, Belgium because of the GDPR, so we're going to have to substitute something else or what have you, or at least alert you that you need to do something about it. So we do all that work. It'd be kind of like saying, if you had a bakery and you made a loaf of bread, once you've made the bread, you can't say, well, this wheat came from here unless somebody told you that. And so the tell you that is the metadata from the constituent pieces. And it would be as if your loaf of bread in the market had this big rollout piece of paper that said, here's where everything in this bread came from. And then, and since it's virtual because it's data, the people that provided the wheat don't have to get paid until somebody buys the bread. And so, because it's now baked into a piece of bread. And so there's no need for us to stock the wheat. There's no need for the analysts to buy the wheat. They just make their product, and then when they're ready, they put it into Turbine as a new data product. So that's another part of our business model, is to allow analytics people to find themselves in this system. This is, again, very similar to how, like Bloomberg does things in that regard.
In the next episode of our discussion with David, we'll break down several recent solution deployments. In the meantime, you can learn more about Turbine at www.terbine.com.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT ONE HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.